Entire cities evacuated. Winds stronger than a speeding race car. Waves taller than buildings. Hurricanes are among the most powerful forces on Earth. But how does a calm ocean transform into a giant spinning storm visible from space? Every hurricane begins with one thing: warm ocean water. Hurricanes need ocean temperatures of at least 26.5 degrees Celsius or 80 degrees Fahrenheit. The ocean acts like a giant fuel tank, absorbing solar radiation and storing vast amounts of heat energy in its upper layers. This thermal reservoir provides the thermodynamic power needed to spark and sustain a massive storm. As the sun heats the ocean, water evaporates into the atmosphere. The warm ocean acts like a giant fuel tank, transferring liquid water molecules into the air as water vapor gas. Millions of these warm, energetic molecules break free from the ocean surface and rise rapidly. This upward stream of warm, moist air is the raw fuel that will feed the growing storm system. As warm, moist air rises, it leaves behind an area of lower pressure near the ocean surface. Nature hates pressure imbalances. To fill this void, cooler, higher pressure air from the surrounding areas begins rushing inward toward the low-pressure center. This creates a continuous inflow of air, establishing a cycle of rising warm air and rushing surface winds. If air only rushed inward, hurricanes would never spin. The Earth's rotation creates a force called the Coriolis effect. As the incoming air rushes toward the low-pressure center, the rotation of the Earth bends its path. In the northern hemisphere, this deflects the air to the right, causing the entire storm system to spin counterclockwise. This rotation is what turns a group of thunderstorms into an organized cyclone. Now the storm begins organizing itself. More warm ocean water evaporates, feeding the system. As the warm, moist air rises, it cools and condenses into clouds, releasing latent heat. This released heat warms the surrounding air, causing it to rise even faster and lowering the surface pressure further. The storm becomes a self-feeding heat engine, drawing more and more moisture from the warm ocean below. As the storm strengthens, something surprising happens. The centrifugal forces and descending air in the very center clear the clouds away, creating a calm, circular zone. This calm center is called the eye. Inside the eye, winds are light and skies can actually be clear. But surrounding this peaceful center is the most violent part of the entire storm. Surrounding the eye is the eyewall. This is a ring of towering, violent thunderstorms that contains the storm's most dangerous elements. This is where the strongest winds, heaviest rainfall, and most intense lightning occur. The air rushes upward at extreme speeds, making the eyewall the engine room of the hurricane's destructive power. Scientists classify hurricanes using the Saffir-Simpson scale, which ranks storms from Category 1 to Category 5 based on their sustained wind speeds. A Category 1 storm has winds of at least 119 kilometers per hour, causing minor damage. As we move up the scale, the destructive potential grows exponentially. Category 5 hurricanes are catastrophic, producing winds exceeding 252 kilometers per hour, capable of destroying buildings and flattening communities. Strong winds aren't the deadliest part of a hurricane. Instead, storm surge often causes the most destruction and loss of life. As the hurricane's powerful winds spin, they push a massive dome of ocean water ahead of the storm. When this water reaches the shallow coastline, it has nowhere to go but inland, flooding coastal communities with a sudden, powerful wall of water. Hurricanes survive on warm ocean water. When they move over land or colder ocean water, their fuel source is cut off. Without the constant supply of warm, moist air and latent heat, the storm's engine begins to fail. Frictional drag from the land surface also slows down the winds. Within hours, the intense rotation slows, the clouds weaken, and the hurricane slowly dissolves. So every hurricane begins with warm ocean water and a low-pressure area. Earth's rotation starts the spin, evaporation provides the fuel, and the storm grows into one of nature's most powerful atmospheric systems. Hurricanes may look beautiful and organized from space, but on the ground, they remind us just how powerful Earth's atmosphere can be. The ocean provides the fuel, the atmosphere builds the storm, and the Earth's rotation makes it spin.